Alright, this is Mr. Gillum, and today we're going to learn about the fabled hypotenuse leg theorem, and it's for right triangles only. And this will be the last little theorem we need to prove all of our triangles congruent. At least it'll be the last one that we actually use in a high school geometry level class. So hypotenuse leg is what we're going to learn about today. And so we're going to do a little discovery today, do it a little differently. And I'm just going to kind of walk you through some of this stuff, and you could probably figure these out pretty quickly, but there's an important relationship here. And what you're going to find is this hypotenuse leg thing, when we get to it, only works for right triangles, and there's a reason it only works for right triangles. Okay. So first things first, let's just do this little warm up here. How long is AC? How far is it from here to here? Oop. From here to here. That's what we want to know first. So since we have practiced the Pythagorean theorem in the past, or you might know it's a 3, 4, 5 right triangle, we can do it either way. I know that a leg squared plus leg squared should equal the hypotenuse squared, which is the longest side of the triangle. So if I did, since we didn't know this, if I did say x squared plus 4 squared equals 5 squared, like so, and I solved for my x value, then I would know that x could equal positive or negative 3, but since we're talking about a distance, x in this case would equal 3. So the distance would be 3. And so similarly, if I solve another triangle, kind of the same way, x, z, y, I could do all the work again, but as you can see, obviously I'm going to get the same side length here of 3. All right, so AC must be 3, x, z must also be 3. It's going to be the same exact steps. So therefore, I know for sure that since through side, 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 that these are definitely going to have to be congruent triangles, or through side, angle, side, or through angle, angle, side. I mean, I could do, well, not angle, angle, side, I guess. But I could do that. I know they're congruent, so yes, they are. They must be. And so let's take a look at another one here. Are they congruent below? So once again, this is another perfect trinomial, or no, sorry, Pythagorean triple. And so I could do some work, but really I know this is going to be 12 on both of these. And to prove it, I could do the Pythagorean theorem. Once again, this is a leg, and the hypotenuse is across from the largest angle. So in this case, 13. 5 squared, and of course we don't know the missing side, the CB, we don't know that side yet. X squared plus 5 squared should equal 13 squared, and if I do a little algebra here, then I can find what the x value is. And like I said, I already knew this was a Pythagorean triple, and we don't need the negative value because we are not referring to a negative anything when we're talking about distance. So x equals 12, and now once again I could do the same steps, but as you can see, if I'm doing the Pythagorean theorem, I'm just going to have to do all this work again to get the same answer of 12 for that one. And I believe this is also a Pythagorean triple as well, but I don't remember it. So let's do this one the long way. This is a leg that we don't know. Oops, it's not a leg squared, it's just a leg. So let's go ahead and try to figure it out. But Pythagoras said there is a relationship in right triangles that you can square the first leg and add it with the square of the second leg. And it'll equal the square of the third leg. So we have 49 plus x squared equals, let's see here, 25 times. 25 times 25, I should probably know. I think it's 625, but I want to make sure I don't put the wrong number on here. 625, okay, yep, I was right. 625, and then I do my subtraction. Oh, let's see here, it'd be 576, and if I take the square root of that, then I know x equals plus or minus 24. Well, in this case, x equals 24 because once again we're talking about a distance. So I know this distance right here, even though it doesn't really look like the right distance, is actually going to be 24 because the square root of 576, if you want a little review on that, 2 times 288, 2 times 144, 12 times 12, 4 times 3, 4 times 3, 2 times 2, so we can do it the old-fashioned way as well if we weren't sure. exactly what the square root was, and I think it's good to review this anyway. There's a 2, there's a 2, there's a 2, and there's a 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. So 24. Yep, the square root of 576 is in fact 24. So okay, so here's what we're getting at really. Even though that's not really drawn to scale, that's 24. What I have here is, on each of these triangles, is I have a right triangle, and what I have is, for the given information, is a hypotenuse and a leg, and of course the right triangle. So all I have is a hypotenuse and a leg, and now this is a right triangle thing. So the theorem itself says that if you have the hypotenuse and a leg of a right triangle and it's congruent to the corresponding hypotenuse leg of another triangle, then those triangles are congruent, as long as it's a right triangle. So it's technically a version of side-side angle, and don't be going around switching those letters around. It needs to be side-side angle, but it only works for right triangles. And so we don't call it side-side angle. That'd be confusing. You don't want to get mixed up with our other theorems, our side angle side, our side side side, our angle side angle, and our angle angle side. This is a specific side side angle, only works with a right triangle because of the relationship between the lengths of the sides and Pythagoras' theorem. Okay, so so as you can see, it would be a side side angle, but like I said, it's only on right triangles, so we don't call it side side angle. We call it hypotenuse leg because you have the hypotenuse and a leg of two different right triangles, and they're in the corresponding positions. So side side angle, but we don't call it that. We call it hypotenuse leg, and it's only for right triangles. Okay, it doesn't work for regular triangles, or I shouldn't say regular triangles, I should say obtuse triangles or acute triangles. It doesn't work the same way. So the hypotenuse leg theorem. And so if I was writing a 2-column proof, and I'm sure you want me to go ahead and cover this up, even though I know you're going to pause the video and just write it all down at once. When you think about this here, okay, it says write a 2-column proof. It says AD is perpendicular to CB. So this is going to be important right here, this little right angle. And CA is congruent to AB. CA is congruent to AB. All right, proof triangle ACD is congruent to ABD. All right, so first things first, I'm trying to do this triangle with this triangle. Trying to prove that those two triangles are congruent. So it's important to remember the things that we have in common here. What I need to make sure of, since these are right triangles, I know there's special relationships that we can talk about. Since I'm trying to incorporate the hypotenuse leg theorem, I want to make sure I use that. Right now I know that the hypotenuse of each of these triangles is the same. If only I knew if one of the legs was the same. Well, luckily this guy right here is shared, so we know that one of the legs is the same. So after our given information, once again we have the reflexive property, they share a side. It's equal to itself. We know this for a fact. And then finally, if we have a side-side angle, we don't call it that, we call it hypotenuse leg because it's a right triangle, and the Pythagorean theorem says that there's no need to do all that work twice. We know for sure if they share a hypotenuse and a leg in common, and it's corresponding in both triangles, then for sure the triangles must be congruent through the hypotenuse leg theorem. All right, and so that's it for the hypotenuse leg. Much less confusing probably than angle, side angle, those types of things. But you'll have some proofs to do on Monday, and that's it for today.